All right, what's up, guys? In this video, I'm going to do some more calculus here. We're going to do another integration practice video. So we got a definite integral. It's going to be from 0 to 1. We got x times x plus 1 raised to the 10th power dx. All right, so just start with a substitution. So let's let u equal x plus 1. We'll take the derivative, which will result in us just getting dx. So what's going to happen is we're going to end up with the integral x times u raised to the 10th power du. Now notice that I left the bounds blank since we're doing a substitution for a definite integral. We'll have to change the limits anyway. Now don't panic, because I do understand that we need everything in terms of u, and we do still have an x floating around. And I try telling students all the time not to panic about this. If you can use your substitution that you did to solve for the variable that's remaining, then do that, and you can still do the integral. If there's no way for you to get rid of this pre-existing variable that you started with, well, then you either picked the wrong u or you're using the wrong technique. So in this case, we're not going to panic about the fact that the x is still there. Let's just go back to the substitution and use the substitution itself to solve for x. So if we do that, we'll get x is equal to u minus 1. Okay, if we solve for x there, or x is equal to x is equal to u minus 1. Sorry, just trying to think there, because we would subtract 1 from both sides. So what that means is what you have now is the integral, and it looks like we'll have u minus 1 multiplied by u to the 10th power du, and I'm just going to bring the u to the 10th power to the front instead of into the back, and you can do that. That's nothing wrong with that. Doesn't make a difference how you distribute it in, and I'm going to write it that way. Now go ahead and distribute in the u to the 10th and expand it out, and again we'll change the limits here in just a second. Let's expand everything out first. So if you expand everything out, you end up with u to the 11th power minus u to the 10th power, and then du. Now let's change the limits. So go back to the substitution. We had u was equal to x plus 1. So stick in a 0, so that's going to be 0 plus 1, which is 1. And then it's going to be 1 plus 1, which is 2. So the new limits of integration are going to be from 1 to 2. And then you'll have u to the 11th power minus u to the 10th power, and then du. So this is the integral you'll have after doing all that. Now you can use properties of definite integral and write it like this. The integral from 1 to 2, this will be u to the 11th power du, and then this will be minus the integral from 1 to 2, and this will be u to the 10th power du. Okay, and you kind of break them up and do them separately. So we'll do that in this video. So it's going to be from 1 to 2. Let's just go ahead and do it. U to the 11th power of du. So that's going to be u to the 12th power divided by 12, and it's going to be from 1 to 2. Now the numbers here are going to get quite big, so you need to have a calculator. So that's going to be 2 raised to the 12th power. We can divide that by 12 and see how that reduces down. So it looks like we'll get 1024 divided by 3. Again, use a calculator. The number's a little big, and sticking in a 1, that's obvious. That's just going to be minus 1/12. So again, use a calculator to plug that in there. So then you would just have 1024 divided by 3 minus 1/12. Excuse me. And you'll, wait a minute, divided by 3 minus 1/12. So we'll get 1,365 all over 4. Excuse me. Okay, then when you move on to the next piece, which would be from 1 to 2, and we got u to the 10th power du. Same idea here. I'm going to get a calculator Now 11 is a prime number, so I know it's not going to really simplify down any. Excuse me, guys. So this is going to be 2048 divided by 11. Again, 11 is a prime number, so, and we do have common denominators, so we can easily just subtract the numerators. And so in this case, this would be 2047 all over 11. So then you just take the 1,365 divided by 4 and subtract that from 2,047 divided by 11. And again, you need common denominators to add and subtract fractions, so you'll need to use a calculator to get an accurate answer. So I'll put down a calculator. We got 1,365 divided by 4 minus 2,047 divided by 11. And we'll convert that to a fraction. And it looks like we get 6,827 divided by 44, which will actually be the answer. So it's going to be 6,827 divided by 44, which is the actual answer. So your final answer for this definite integral is going to end up being 6,827 divided by 44. All right, so let me circle that for you, and that's the solution. All right, so if you guys have any questions about how I got my answer, please let me know. I'll be more than happy to explain it in greater detail. All right, I'll see you guys next time. Y'all take care.